Hello everyone. Tonight we dive deep and take stupidest things tried in space. Now, dim the lights and let's ease into tonight's journey together.
In the high-stakes world of space exploration, you'd expect every detail to be controlled, measured, and rehearsed with military precision. And most of the time, it is. But every so often, a moment of human impulsiveness or bizarre decision-making sneaks past the layers of protocol. And sometimes, it's as ridiculous as a sandwich floating in zero gravity. The year was 1965. The United States was in the midst of the Gemini program, a critical stepping stone between Mercury and the eventual Apollo moon landings. Gemini 3 was set to be the first manned flight of the program, a test of spacecraft maneuverability, systems endurance, and human response to multi-orbit flight. The commander was none other than Gus Grissom, a veteran of the Mercury program, and alongside him sat John Young, a future Apollo astronaut. What could possibly go wrong? Enter the corned beef sandwich. Young, ever the mischievous astronaut, had smuggled a sandwich into space. A seemingly harmless prank. But this wasn't just a funny moment of rebellion. The sandwich, which he had hidden in his spacesuit, was from a deli in Cocoa Beach, Florida. It was carefully unwrapped mid-mission and shared with Grissom, who took a bite before the two realized they might be in trouble. The problem wasn't the sandwich per se, it was the crumbs. In zero gravity, every small particle behaves differently. Crumbs don't fall to the floor and stay there. They float unpredictably in every direction. That includes inside delicate electronic systems, life support modules, and the astronaut's own lungs. A single rogue crumb could have triggered a short circuit or interfered with air filtration systems. NASA was furious. Members of Congress were not amused either, criticizing the stunt as dangerous and irresponsible. In their words, the Gemini spacecraft had cost millions, and here were astronauts turning it into a flying lunchroom. A full investigation followed. From then on, space food protocols tightened, with strict restrictions on what could and couldn't be brought aboard. This was not just a lesson in risk, it was a reminder that in space, even a joke can have life or death consequences. But the story of strange experiments and ridiculous moments in space doesn't stop at deli meat. In fact, there have been times when the most brilliant minds on Earth greenlit ideas that, in retrospect, seem absurd. One such experiment involved trying to determine the feasibility of nuclear explosions in space. Project Starfish Prime in 1962 was one of the most ambitious and arguably reckless tests ever conducted in the upper atmosphere. The idea was to understand how nuclear detonations would behave in space-like conditions, particularly for military applications. At the height of the Cold War, America wanted to know if nuclear weapons could be used to disable satellites, create radiation belts, or even alter enemy communications. So what did they do? They launched a thermonuclear warhead aboard a Thor rocket and detonated it 250 miles above the Earth's surface, within the Earth's magnetosphere. The results were as visually stunning as they were scientifically chaotic. The explosion created a massive artificial aurora visible from as far away as Hawaii. It also knocked out communications, fried satellite electronics, and created a temporary radiation belt that disabled several spacecraft, including Telstar, a communications satellite meant to revolutionize global TV broadcasting. It turned out that detonating nuclear weapons in space was a terrible idea, not just from a geopolitical or ethical standpoint, but because the Earth's own systems were more fragile than anyone realized. The radiation lingered in low Earth orbit, becoming a danger to other satellites and potentially to future astronauts. This bizarre experiment taught scientists that space isn't an empty vacuum where consequences disappear. It's an interconnected system that reacts in sometimes unpredictable and damaging ways. But if you think that's bad, consider the time someone thought it would be a great idea to spray graffiti in space. In 2018, a startup called Rocket Lab launched a satellite called Humanity Star. It wasn't a satellite with sensors or scientific goals. It was essentially a giant, shiny disco ball. Its purpose? To create a bright reminder to look up and reflect on our place in the universe. While poetic in intent, the satellite drew immediate criticism from the astronomical community. It reflected sunlight back to Earth, creating a new artificial star that outshone natural ones, interfering with telescopes and the study of the night sky. Astronomers argued that space shouldn't be a canvas for artistic stunts. It's a shared resource, a fragile domain, and disrupting it for branding or vanity projects sets a troubling precedent. The Humanity star burned up in the atmosphere just a few months later, its orbit having decayed faster than expected. But it sparked a bigger debate. Who gets to decide what is sent into space and for what purpose? Should space be used for advertising, art, or even self-promotion? As more private companies race to launch objects into orbit, concerns about space clutter and space ethics grow louder. The weird doesn't stop there. In 2006, NASA decided to test how certain items would behave in microgravity. Some of these made perfect sense. Tools, parts, seeds, even living organisms. But one of the items aboard the STS-121 mission was a lightsaber. Yes, that lightsaber from Star Wars. Specifically, it was the actual prop used by Mark Hamill as Luke Skywalker in Return of the Jedi. NASA flew it into space aboard the Space Shuttle Discovery as part of a promotional collaboration with Lucasfilm to celebrate the 30th anniversary of the franchise. While this didn't risk the safety of the crew, it's a prime example of how the line between science and pop culture gets blurred in orbit. The lightsaber was safely returned to Earth and now rests in a museum, having orbited the planet in real life just as it did in fiction. And speaking of stunts, in 2018, SpaceX launched Elon Musk's personal Tesla Roadster into space aboard the maiden flight of the Falcon Heavy. The car was fitted with a mannequin in a spacesuit dubbed Starman, with David Bowie's Space Oddity playing on repeat from the stereo. It was a stunning PR moment, but to scientists, it also raised serious concerns. Cars aren't built for space. The materials degrade quickly in radiation. Tiny fragments can break off and add to the growing problem of space debris. Critics pointed out that space shouldn't be a junkyard for Earth's luxury toys, but defenders argued that it inspired millions to dream of the stars, something few sterile satellites could accomplish. As bizarre as these stories are, they reveal a recurring truth. Space is still human. For all our technological advancements and scientific rigor, we carry into orbit the same traits we exhibit on Earth: curiosity, ego, creativity, recklessness, and sometimes just plain stupidity. Even the smartest scientists and most elite astronauts are not immune to moments of madness or mischief. More tales of cosmic absurdity are waiting to be told, from exploding beer cans to illegal moon graffiti, all showcasing just how surreal our ventures into the final frontier can become. For as long as humans have gazed up at the stars, we've carried dreams of exploration and the desire to bring a little comfort from Earth with us. Once the early milestones of reaching orbit and surviving re-entry were achieved, attention turned to the more human side of space travel. What would it take to live up there, not just survive? And for some people, that included beer. The idea of drinking alcohol in space might seem harmless at first. After all, astronauts are among the most rigorously trained individuals on Earth. Surely they could handle a little celebration. But as with everything in space, even the simple act of sipping a beverage comes with unforeseen consequences. In the 1980s, as long-duration spaceflight became more routine, astronauts began requesting more Earth-like experiences. That's when companies like Anheuser-Busch saw an opportunity. They partnered with researchers to develop a beer that could potentially be consumed in space. The first issue was technical. Carbonated liquids behave very differently in zero gravity. On Earth, bubbles in beer rise to the top, allowing gas to escape harmlessly into the air. In space, however, there's no up. The carbon dioxide remains evenly distributed in the liquid, which makes it nearly impossible for the body to burp out the gas after swallowing. The result? Painful bloating, intense discomfort, and what astronauts began to call wet burps, a combination of gas and liquid coming back up at once. But the problems didn't stop there. In 2001, Australian researchers brewed a special space beer to test whether certain yeast strains could ferment properly in microgravity. Meanwhile, Anheuser-Busch launched barley seeds into orbit aboard SpaceX missions, hoping to study how microgravity affects crop growth. These initiatives were marketed as science, but the ultimate goal was to lay the foundation for future interplanetary breweries. The challenge was not just physiological, but also cultural. NASA maintained strict no-alcohol policies after an incident aboard Skylab in the 1970s, where astronauts allegedly smuggled small amounts of alcohol aboard and consumed them without permission. The agency's stance became firm: no intoxicants in orbit. The risks were too high and the optics too damaging. That didn't stop Russia from doing things a little differently. During the Soviet era, cosmonauts were routinely issued small rations of cognac or brandy for medicinal purposes. The logic was that alcohol could help with relaxation, stimulate appetite, and reduce stress, especially during the isolation of long missions. Cosmonauts on Mir and even some early ISS expeditions hinted at unofficial drinking rituals, though none were formally acknowledged by Roscosmos. Eventually, concerns about alcohol's impact on coordination, judgment, and emergency response overrode the tradition. Today, alcohol is officially banned on the International Space Station, but rumors of special occasions persist. And yet, the obsession with drinking in space continues. A company called Four Pines Brewing in Australia even developed a beer called Vostok, named after Yuri Gagarin's spacecraft. Marketed as the first beer designed specifically for spaceflight, it had reduced carbonation and increased viscosity to make it easier to swallow in zero gravity. They tested it aboard parabolic flights, planes that simulate weightlessness in short bursts, to see how it behaved. The result? Still not ideal, but a fascinating experiment in human indulgence pushing the boundaries of physics. All this leads to a broader question. Should space be a place of pure science and survival, or should we make it as comfortable and familiar as possible? Trying to smuggle luxuries into orbit isn't a new idea either. On several Apollo missions, astronauts brought unauthorized items aboard. Charlie Duke of Apollo 16 famously left a photo of his family on the lunar surface, while Alan Shepard smuggled a makeshift golf club to play the most famous round of golf in history, on the moon. These acts weren't stupid in the traditional sense, they were deeply human. But they did raise eyebrows among mission control and set a precedent for bending the rules. The line between celebration and recklessness has often been blurred. In one infamous case, the crew of Skylab 4 became so overwhelmed by mission demands and long work hours that they simply turned off communication with mission control. Dubbed the Skylab Mutiny, the astronauts took a full day off without permission, refusing to respond to commands and spending the time gazing at Earth, relaxing, and regaining composure. It was perhaps the first recorded space strike. NASA quickly realized that long-duration missions required not just physical planning, but psychological support. A burned-out astronaut is a liability, and even a highly trained individual can reach a breaking point when confined in a tin can hurtling through orbit. Fast forward to the present, and we find more examples of outlandish ideas being proposed, if not always executed. There have been serious proposals to send pizza ovens, pianos, and even inflatable concert halls into orbit. While some of these might be justified as morale boosters, others teeter on the edge of absurdity. In 2015, a Japanese company launched a satellite designed to release tiny pellets to create artificial meteor showers on demand. The goal? Space fireworks. The project was not cheap, costing millions of dollars, and its scientific value was questionable. Critics argued that the space environment should be preserved for critical research and exploration, not turned into an entertainment venue. Even stranger is the persistent desire to put fast food into orbit. Taco Bell once considered sponsoring a space stunt involving a giant floating target in the ocean. If a piece of space debris hit the target, they promised free tacos for every American. Though the campaign was ultimately scrapped, it illustrates just how far brands will go to insert themselves into space narratives. It's hard to imagine Newton or Galileo dreaming that their scientific legacy would someday lead to orbital junk food promotions. But perhaps the most ridiculous and dangerous space idea of all time came from Project A119. This was a secret US Air Force plan in the 1950s to detonate a nuclear bomb on the moon. The idea was to create a visible explosion as a show of force during the Cold War, proving American superiority in space. The plan was real. Detailed studies were conducted. Carl Sagan, in fact, worked on some of the theoretical models during his early career. The project was ultimately abandoned, thank goodness. The risk of contaminating the moon, disrupting its orbit, or triggering unknown geological consequences was deemed too great. But the fact that it was even considered is a testament to how wild our space ambitions and egos can become. There's a pattern here. For every great leap in science and discovery, there's an equally baffling, sometimes childish urge to leave a personal mark or break the rules. Whether it's drinking beer in orbit, launching a sports car to Mars, or fantasizing about lunar nukes, human nature insists on making the cosmos a stage not just for science, but for spectacle. And as we continue to commercialize and colonize space, that urge will only grow louder. It's arguably the most iconic achievement in human history. July 20th, 1969, when Neil Armstrong stepped onto the moon and said, "That's one small step for a man, one giant leap for mankind." The moment was beamed to millions around the globe. Grainy, black and white images transmitted from 240,000 miles away. For many, this broadcast was the peak of 20th century human ingenuity. So, naturally, one would assume NASA would take exceptional care to preserve the original footage of the moon landing. Yet, in one of the most baffling bureaucratic blunders of all time, NASA lost the tapes. Not just misplaced, erased. This was not a conspiracy, nor was it part of some elaborate cover-up. It was, in the most mundane and frustratingly human sense, a case of poor file management and tape recycling. In the early 2000s, as enthusiasts and historians sought to restore the Apollo 11 footage, they went looking for the original SSTV, slow-scan television, recordings. The raw data sent from the lunar module before it was converted for television broadcast. What they found was shocking. The tapes were gone. After a lengthy internal investigation, NASA concluded that the original Apollo 11 SSTV recordings had likely been overwritten in the 1980s, during a period when magnetic data tapes were being routinely recycled due to budget constraints and storage shortages. Yes, the best visual record of humanity's first steps on the moon, recorded with specially designed equipment, transmitted across space, and stored in hopes of preserving it for all time, was likely taped over with satellite weather data or engineering telemetry. This wasn't the result of sabotage or negligence at the highest levels. It was something far more mundane, a lack of foresight combined with the reality that in the analog era, magnetic tape was both expensive and bulky. Storing and maintaining hundreds of thousands of reels required space, money, and a sense that the contents would be useful again. To some bureaucrats at the time, 1969 was ancient history. The mission had already been televised, archived in a different form, and stored in edited formats. But those versions were significantly degraded. The original SSTV footage was far higher in quality than what the public saw, offering more detail, better contrast, and cleaner visuals. The world never got to see it in its full glory. Efforts were later made to restore and enhance the remaining footage. Using backup broadcast recordings and advanced digital processing, engineers managed to improve the quality somewhat. But the originals, gone forever. a permanent casualty of bureaucratic cost-cutting. This moment stands as a symbol of just how fragile even our most important cultural artifacts can be in the face of institutional myopia. When space agencies focus so hard on the next big thing, they sometimes forget the importance of preserving the past. And NASA isn't the only agency guilty of space-related mishaps born from good intentions gone wrong. Take the time the Soviet Union tried to put a giant mirror in space. It sounds like something from a science fiction novel, but in 1993, Russian scientists launched a spacecraft named Znamya-2, a prototype for a project designed to illuminate parts of Earth using a massive orbiting mirror. The idea was to reflect sunlight down to dark or remote areas, extending daylight hours, reducing energy use, and potentially even supporting agriculture in northern latitudes. Znamya-2 consisted of a circular sheet of reflective mylar, 20 meters in diameter, attached to a Progress supply ship that had just finished a resupply run to the Mir space station. Once deployed, the mirror unfurled like a giant parasol and reflected a beam of sunlight roughly 5 kilometers wide across the Earth's surface. For a brief moment, parts of Europe saw a ghostly streak of moving light at night, a manufactured moonbeam drifting across the landscape. It was both eerie and impressive. The next phase was even more ambitious, Znamya 2.5, with an expanded mirror nearly 25 meters wide. But this time, the deployment failed. The mirror got stuck and began to tumble uncontrollably. The mission had to be scrapped, and the mirror burned up in Earth's atmosphere shortly after. While the project had noble goals, it also raised serious concerns. Astronomers warned that massive orbiting mirrors could disrupt telescopic observations. Ecologists pointed out that artificial light at night has known effects on animal behavior and human circadian rhythms. Others worried about the militarization of such a system. What if it were used to blind or disable targets with focused beams of sunlight? The Russian space mirror wasn't the only time someone thought it'd be smart to artificially manipulate light in orbit. Around the same time, another proposal emerged, turning satellites into massive advertising billboards. In the late 1990s, a US company called Space Marketing Inc. wanted to launch a billboard satellite roughly the size of a football field into low Earth orbit. The concept was to create giant reflective panels that would form a logo visible from the ground. People on Earth could look up and see corporate branding lighting up the night sky. The backlash was immediate. Astronomers, environmentalists, and everyday citizens pushed back hard. The idea of turning the sky into a corporate billboard was seen as the ultimate insult to the sanctity of space. Even Congress got involved. In 2000, the US passed legislation that effectively banned any advertising satellites visible from Earth's surface. But the idea keeps resurfacing. As satellite technology gets smaller and cheaper, companies have begun exploring high-altitude drones, tethered balloons, and orbital cubes that could form patterns or messages. The boundary between awe and absurdity continues to be tested. These stories highlight a recurring theme: our inability to separate "can we" from "should we" when it comes to space. Just because technology allows something to be done, whether it's launching a space disco ball, firing a car into heliocentric orbit, or attempting to light up Siberia with a 20-meter mirror, doesn't mean the consequences have been thoroughly thought through. Another infamous example comes from the space shuttle era, when mission planners decided to test how fluids behave in orbit by releasing various substances into the vacuum of space. Most were water-based or related to engine exhaust. But one time, they experimented with paint. In a bizarre sequence of events during the STS-6 mission in 1983, engineers coated parts of the shuttle's external fuel tank with a new type of paint intended to reduce icing and improve thermal regulation. But once in space, the paint began to flake off, creating thousands of tiny particles in orbit. These particles didn't pose a massive threat on their own, but they added to the growing concern about space debris. Each piece, no matter how small, travels at tens of thousands of kilometers per hour. A fleck of paint moving at orbital velocity can shatter windows or damage insulation. NASA learned an expensive lesson about testing materials before launching them into space. By the mid-2000s, space debris had become one of the most pressing concerns for all spacefaring nations. Everything from defunct satellites to tools lost by astronauts. Yes, even a tool bag accidentally let go during a spacewalk was now a hazard. Every misstep, every forgotten wrench, every flaking paint particle contributed to the orbital minefield that circles our planet today. Human error, hubris, and ambition have all left their marks on the sky. And as space becomes more accessible, the chances of new absurdities only increase. More companies, more countries, and even individual hobbyists now have the power to launch payloads into orbit. With that comes incredible opportunity, but also a risk of repeating the same mistakes, only bigger and faster. Long before humans ever left Earth's atmosphere, space agencies around the world sent animals into orbit to study the effects of microgravity, radiation, and re-entry on living organisms. The logic was sound. If animals could survive the journey, maybe humans could too. But the execution, often clumsy, questionable, and, in some cases, downright disturbing. The most famous example is Laika, the Soviet space dog. In 1957, Laika became the first animal to orbit Earth aboard Sputnik 2. She was a stray, plucked from the streets of Moscow, and selected for her small size and calm temperament. The Soviet Union was in a race to prove their technological superiority over the United States, and Laika was to be their shining symbol. But the mission was never designed to bring her back alive. The spacecraft lacked re-entry capability, and her cabin was hastily constructed, offering only the most basic life support. Soviet officials initially claimed that Laika had survived for several days before being painlessly euthanized. But decades later, the truth emerged. Laika died just a few hours after launch, likely from overheating and panic. The temperature control system had failed, and telemetry showed rising distress. Laika's sacrifice sparked global outcry and debate about the ethics of animal testing in space. While some hailed her as a hero, others saw her as a victim of political ambition. The event forced scientists and space agencies to rethink how animal experiments were conducted. Unfortunately, Laika was just the beginning. Over the years, a menagerie of creatures has been launched into space. Mice, monkeys, frogs, turtles, fish, jellyfish, spiders, bees, and even cockroaches. Some experiments were meant to test basic biology, like reproduction in microgravity. Others were little more than science fair projects with living cargo. In one experiment in the 1970s, the Soviets launched a mission with a group of tortoises aboard a Zond spacecraft to orbit the Moon and return. They wanted to study the effects of deep space travel. The tortoises made it back safely, but the mission raised eyebrows. Why tortoises? Because they're hardy, low maintenance, and expendable, a convenient choice for a risky experiment. NASA, too, has had its share of questionable animal missions. During the 1960s, they launched chimpanzees into suborbital and orbital flights. The most famous was Ham, a chimp trained to pull levers in response to lights and sounds, demonstrating that complex tasks could still be performed in space. Ham's flight aboard a Mercury capsule was a success, and he survived. But the stress he endured was severe. During ascent, the rocket over-accelerated, and during splashdown, the capsule took on water. It was a terrifying ordeal for any living being. Ham eventually became something of a celebrity, living out his days at a zoo. But other chimps weren't so lucky. Many died in training or in-flight failures. Critics argued that these primates, so closely related to humans, deserved better than to be treated like disposable lab equipment. Some experiments crossed into the bizarre. In 1973, aboard Skylab, NASA sent up a group of common house spiders to see how they would build webs in zero gravity. Scientists wondered, would they still be able to orient themselves and construct symmetrical structures without the guidance of gravity? The results were fascinating and a little creepy. The spiders adapted quickly, creating webs that were messier and more asymmetric than usual, but still functional. It was a success in terms of learning about animal adaptability. But as photos of the floating arachnids made their way to the public, many couldn't help but ask, who thought spiders in space was a good idea? Then there was the infamous frog flinging experiment. NASA once launched an experiment to study how amphibians orient themselves in a weightless environment. The mission used African-clawed frogs, which were placed in enclosed, fluid-filled tanks. At random intervals, puffs of air would be released to stimulate them. The frogs, disoriented, would then perform a maneuver called the frog kick, pushing off in whatever direction they could. The data was useful, but to many, the optics of launching live frogs into orbit just to see them flail around felt more like a college prank than legitimate science. The story gets even stranger when we look at animal reproduction experiments. In the 1990s, NASA conducted experiments with Japanese medica fish, a species known for its fast reproduction cycle. The fish mated in space and successfully produced offspring, an important milestone in understanding long-term human colonization. But similar experiments with rats and mice yielded mixed results. In some cases, males refused to mate in microgravity. In others, pregnancies failed mid-gestation. It turns out that fertilization, and development, and even birth itself are deeply tied to Earth's gravity. These studies were critical, but they also opened ethical Pandora's boxes. Should we be forcing animals to experience the confusion and stress of microgravity only to study their reproductive failures? Perhaps the strangest chapter came in 2007, when tardigrades, tiny, water-dwelling microanimals, were sent into open space without a spacecraft. Scientists wanted to see if anything could survive direct exposure to the vacuum and radiation of space. Amazingly, the tardigrades did. They were exposed for more than a week, floating naked in the harshest environment imaginable. Upon returning to Earth, many were still alive. These creatures, smaller than a pinhead, had essentially shrugged off space itself. The experiment was scientifically valuable, demonstrating the potential for life to survive interplanetary travel. But it also blurred the line between daring exploration and mad science. There's a certain unease when it comes to launching living beings into space without their consent. Even if they're insects or microbes, these are sentient organisms, sacrificed in the name of progress. While science often involves difficult trade-offs, space has a way of amplifying the absurdity and ethics of those choices. In recent years, the focus has shifted toward in vitro experiments and organ-on-a-chip technologies that reduce or eliminate the need for live animals in space. But the legacy of bizarre and morally complex experiments remains. One could argue that the willingness to treat life forms as test subjects, no matter how small, reflects a fundamental contradiction in human nature. Our quest for knowledge often outpaces our capacity for empathy. And as space exploration moves beyond government agencies and into the realm of private enterprise, the question remains: who will regulate what can and cannot be done with living beings in orbit? Spacewalks, or EVAs, extravehicular activities, are among the most dangerous and delicate operations astronauts can perform. Every movement outside the spacecraft must be deliberate, rehearsed, and performed with the utmost care. There's no margin for error. One wrong move, one dropped object, and it can be lost to the vacuum of space. Forever. Which brings us to one of the most embarrassing moments in spacewalk history, the Great Tool Bag Incident of 2008. During a routine spacewalk from the International Space Station, astronaut Heidemarie Stefanishin Piper was tasked with performing maintenance on a jammed solar panel rotation joint, part of an essential system that helps the station orient its massive solar arrays. She was trained, focused, and highly experienced. But as she opened her tool bag to begin the work, a small amount of grease leaked out, coating her gloves and tools. While trying to clean up the mess, she momentarily lost her grip. In that brief lapse, the entire tool bag, filled with wrenches, tethers, and grease guns, drifted away. Slowly, majestically, irretrievably. The bag floated off into space, becoming its own tiny satellite. For weeks, it remained in low Earth orbit, visible with the help of a telescope or good binoculars. Amateur astronomers even tracked it on websites dedicated to satellite spotting. For a time, it was among the brightest man-made objects in the sky. NASA was not pleased. The bag and its tools were worth over $100,000, and the mishap forced Mission Control to hastily reconfigure the rest of the spacewalk using backup tools. Stephanie Piper remained composed and professional, completing the EVA with her partner despite the setback. But the image of a lone tool bag drifting through space became a symbol of how even the most advanced operations can go sideways due to the smallest mistake. The incident also highlighted a major challenge in space operations: the problem of floating debris. While a drifting tool bag might seem harmless, or anything in orbit poses a threat. Even small objects can cause catastrophic damage due to their immense velocity, up to 28,000 kilometers per hour. The tool bag was tracked closely until it eventually deorbited and burned up in Earth's atmosphere several months later. But it's far from the only object humans have accidentally or intentionally abandoned in space. Throughout the history of spaceflight, we've left behind cameras, gloves, spatulas, bolts, bags of urine, and even a camera lens cap on the lunar surface. During one Apollo mission, an astronaut's wrist mirror broke off and floated away. During another, a thermal blanket slipped out and became its own orbiting object. Some astronauts have described seeing bits of paint or insulation peel away and spin past the windows of the spacecraft. Each piece adds to the growing field of space junk, a term that sounds funny but has serious implications. As of today, tens of thousands of pieces of debris larger than a marble are being actively tracked by ground radar. Millions more pieces too small to detect still zip around in unpredictable paths. The fear is what scientists call the Kessler syndrome, a cascade effect where one collision causes a debris cloud which hits other objects, creating even more debris, and so on, eventually rendering some orbital altitudes unusable. A single lost tool bag is unlikely to trigger such a scenario, but it serves as a reminder that space is not a vacuum of forgiveness. Ironically, the space community refers to these drifting objects with a kind of affection. Items like the tool bag are listed in satellite catalogues. They have IDs. Some have orbital elements calculated just like functioning spacecraft. For a brief time, the tool bag was technically one of the most well-known satellites of the 21st century. Only it wasn't sending data or exploring the cosmos. It was just floating garbage. But NASA and other space agencies aren't always the culprits when it comes to debris. In 2007, China conducted an anti-satellite test, ASAT, deliberately blowing up one of its own defunct weather satellites with a ballistic missile. The result? Over 3,000 new pieces of trackable debris, and countless smaller fragments. It was widely condemned as reckless and short-sighted. Just 2 years later, an active US Iridium satellite accidentally collided with a defunct Russian satellite, creating another massive cloud of space junk. These weren't tool bags. These were multi-ton machines smashing into each other at hypersonic speeds, each collision spreading shards in every direction. In this context, the drifting tool bag becomes a strange sort of metaphor. It's a benign symbol of human fallibility. It didn't explode, it didn't cause a chain reaction, but it did show that even in space, with all our planning and precision, things still go hilariously or dangerously wrong. And sometimes, the stupidest things tried in space aren't decisions made on the ground, but split-second accidents in orbit. This brings us to the broader challenge of astronaut error. During a 1994 spacewalk from the shuttle Endeavour, astronaut Mark Lee nearly drifted away from the spacecraft due to a stuck tether. He was testing a prototype jet-powered backpack that allowed untethered maneuvering, a device that worked perfectly in simulations. But the test didn't go as planned, and Lee's movement was unpredictable. He managed to regain control and return safely, but the incident underscored how even the most exciting new gadgets could go dangerously awry in real-world conditions. The backpack, called Safer, simplified aid for EVA rescue, is still used today, but it's considered an emergency tool, not a freedom device. Similarly, on the Russian side, a cosmonaut once used a power drill on a space station repair mission and accidentally punched a hole in the outer layer of the structure. The damage didn't compromise the habitat, but it required immediate patching and a stern lesson. Even tools need a learning curve in zero-G. In space, there is no second chance. A dropped tool becomes a threat. A slip of the hand becomes a broadcasted headline. Every object, every action becomes part of the orbital ecosystem, sometimes for weeks, sometimes for decades. That's why, today, every spacewalk is preceded by countless hours of underwater training, VR simulation, tool checks, and choreography. Yet even with all that, the human factor remains. And perhaps that's what makes these mishaps so fascinating. Space is supposed to be pristine, scientific, and calculated, but humans bring their quirks, their oversights, and their moments of unintentional comedy with them wherever they go, even to the stars. The moon is a place of mystery, grandeur, and some of the most unexpected human antics in space history. When astronauts first set foot on the lunar surface, it was a moment of solemnity, scientific significance, and international awe. But not long after those first historic footprints, things got weird. Let's start with one of the more surreal facts. There's a golf ball on the moon. During the Apollo 14 mission in 1971, astronaut Alan Shepard famously smuggled a makeshift 6-iron head and attached it to the handle of a soil sampling tool. After completing the official mission objectives, he revealed the club and 2 balls to the surprise of everyone, including mission control. Clumsily swinging in his bulky pressurized suit, Shepard hit both balls across the lunar surface, exclaiming that the second went miles and miles and miles. In reality, it went about 40 yards. But that didn't matter. It was the first, and so far only, golf shot ever taken off Earth. Shepard later admitted it was part showmanship, part morale booster. But the move drew mixed reactions. Some saw it as a charming human gesture amid high-tech achievement. Others called it a dangerous distraction and a waste of precious cargo space. It also raised a question: what else were astronauts smuggling to the moon? Turns out, quite a bit. While NASA's official manifest was meticulous, Apollo crews found ways to bend the rules. During Apollo 15, astronaut David Scott conducted an impromptu physics demonstration inspired by Galileo. With cameras rolling, he dropped a hammer and a feather simultaneously. Because there's no atmosphere on the moon, both hit the ground at the same time, perfectly illustrating gravitational acceleration. Unlike the golf stunt, this moment was pure science, and made up for some of the mission's less graceful moments. One of those was the deployment of the Lunar Roving Vehicle, LRV, NASA's answer to the question, how do we explore more of the moon in less time? Essentially, a battery-powered dune buggy, the LRV was a marvel of compact engineering. It folded up to fit inside the lunar module and unfolded like origami on the surface. But it wasn't without problems. The rover's fenders weren't built to handle the moon's fine dust. On one mission, a fender extension broke off. With no replacement, the astronauts were bombarded with dust while driving, a major visibility hazard. In a stroke of astronaut ingenuity, they improvised a fix using duct tape and lunar maps. Yes, the multi-billion-dollar moon mission was saved, in part, by tape and paper. But perhaps the most absurd part of the lunar rover saga was the fact that astronauts raced it. Unofficially, of course. During Apollo 17, Commander Gene Cernan pushed the LRV to its speed limit, about 11 miles per hour. The footage shows the rover bouncing erratically across the cratered terrain, dust flying behind it. It was risky and dangerous, but it was also a moment of pure joy on a cold, dead world. The moon, in many ways, brought out both the best and strangest in the astronauts. Take the so-called Moon Bible. On Apollo 14, astronaut Edgar Mitchell carried microfilmed copies of the King James Bible and other texts hidden in his suit. They were part of a project by the Apollo Prayer League, which sought to place a Bible on the moon. The plan was largely symbolic, but it sparked controversy over the use of public resources for religious missions. In another case, personal mementos were left behind, ranging from military medals to photographs. These tokens were meant to humanize the mission, but some critics viewed them as clutter. In total, astronauts left over 200 artifacts on the moon, some meaningful, others seemingly trivial. There's even a small aluminum sculpture called Fallen Astronaut, left during Apollo 15. It was placed on the surface along with a plaque commemorating astronauts and cosmonauts who had died in the pursuit of space exploration. The gesture was noble, but NASA hadn't approved it. The artist, Paul van Hooijdonk, later tried to sell copies of the statue, causing further controversy. What was meant as a quiet tribute became a debated act of art, commerce, and protocol. Meanwhile, the Apollo 12 mission had its own moment of ridiculousness. While landing near the Surveyor 3 probe, an unmanned spacecraft sent years earlier, the astronauts retrieved parts from it for study back on Earth, but they also took photos of each other in awkward poses beside the old machine, including one dubbed the robot selfie. The photo was harmless fun, but a later analysis revealed that the astronauts may have unknowingly contaminated the probe with Earth bacteria, giving rise to decades of scientific confusion. When the returned parts were examined on Earth, researchers discovered a strain of Streptococcus mitis, a bacterium common in the human mouth, still alive after years on the moon. Had it survived on the moon, or was it contamination that occurred back on Earth during analysis? No one could say for sure. The incident sparked renewed debate over planetary protection protocols, how to keep Earth microbes from hitching rides to other worlds. While these moments may seem silly, they underscore a serious point. In space, everything counts. Even small indulgences, like playing golf, racing a rover, or carrying a feather, carry risks and ripple effects. The moon isn't just a place of science. It became a stage where human personalities, creativity, and even rebellion played out under the most extreme conditions imaginable. It also revealed something essential about us. For all our caution and planning, humans crave expression, even in a hostile environment. We draw smiley faces in lunar dust. We whisper prayers to dead colleagues. We toss objects just to see how far they'll float. These moments don't make the mission stupid, they make them human. But sometimes the line between touching and absurd is thin, especially when you consider how much each pound of cargo cost to get there. At the time, NASA estimated the cost of launching a single pound of material to the moon was over $20,000. That means every golf ball, Bible, or doodle in the dust had a serious price tag. And yet, for all the cost, these quirks became part of the story. Proof that even in the most alien places, Earth's weirdness follows us. When Elon Musk launched a car into space, space is expensive, complicated, and often deadly serious. But sometimes the sheer scale of ambition leads to actions that feel more like performance art than scientific rigor. Perhaps the most famous modern example, the moment SpaceX launched a cherry-red Tesla Roadster into deep space. It was February 6, 2018. SpaceX, the private space company founded by Elon Musk, was about to test its Falcon Heavy rocket for the first time. At the time, it was the most powerful operational rocket on Earth, capable of sending large payloads beyond low Earth orbit. Rather than load it with dead mass or concrete ballast as a dummy payload, Musk chose something a little more theatrical. He loaded it with his personal car, not just any car, a 2008 Tesla Roadster, symbolic of his other major company, Tesla Motors. The car was strapped to the upper stage of the Falcon Heavy rocket, complete with a mannequin in a SpaceX spacesuit seated behind the wheel. The dummy was named Starman, a nod to the David Bowie song playing on loop through the car's sound system. A message on the dashboard read, "Don't panic," referencing The Hitchhiker's Guide to the Galaxy. The rocket launched flawlessly. After the boosters separated and made their dramatic return landings, the upper stage ignited a final time and sent the car into solar orbit, an elliptical path around the Sun that crosses the orbit of Mars. The livestream went viral. Images of the car floating above Earth, Earth itself glowing in the background, were mesmerizing. It looked like CGI, but it was real. A real car, in space, forever. And reactions were deeply divided. Supporters saw it as a brilliant public relations move, a way to inspire people, to show what private industry could accomplish, to make space exciting again. It wasn't just a test flight, it was a spectacle. In an age of declining public interest in science, the stunt captured imaginations in a way few things had since the moon landing. But critics called it a publicity stunt, a vanity project, an irresponsible use of resources. Launching a car into space, they argued, wasn't exploration, it was brand marketing, wrapped in the aesthetic of sci-fi. There were environmental questions too. Even though the car posed no real threat to planets or spacecraft, it became symbolic of a casual attitude towards space debris and planetary protection. Still, it raised a profound and strange question. What is the point of space exploration? Is it about pure science? Is it about colonizing other worlds? Or is it also about expression, about doing something just because it's never been done before? The Tesla is expected to orbit the Sun for millions of years unless it collides with something. Scientists ran simulations and estimated there's a small chance, roughly 6%, that it will eventually crash into Earth or Venus over the next few tens of millions of years. Until then, it's a literal ghost car haunting the solar system. And it's not the only bizarre object we've sent up recently. In 2019, a startup called Aleph Farms sent meat to the International Space Station, not for consumption, but to grow beef cells in space using 3D bioprinting. The goal was to show how we might one day produce food off Earth. A noble cause, but the headlines ran wild. Lab-grown steak in orbit. Around the same time, a company named Arch Mission Foundation sent a small disk of data storage into orbit, called the Lunar Library. It was filled with thousands of books, human DNA samples, and even a copy of Wikipedia. But hidden inside were also microscopic tardigrades. Again, frozen, dehydrated, and stashed away as part of what the company called a backup of planet Earth. The lander carrying the disk, however, crash-landed on the moon. No one knows for sure if the tardigrades survived impact, but if they did, they could theoretically still be up there, dormant, indestructible, embedded in the lunar surface like space dust time capsules. That sparked outrage from planetary scientists. No one gave permission to send Earth life to the moon without thorough review. The stunt had bypassed regulatory oversight. What was meant as a grand gesture of resilience and preservation had become an international incident in astrobiology ethics. And yet, this merging of science fiction and science fact is becoming increasingly common. Back in 2015, Japanese artist Etsuko Ichihara launched a space funeral. The idea was to send a portion of a loved one's ashes into orbit as a memorial. The satellite, launched aboard a commercial rocket, carried the cremains of several individuals and circled Earth for months before burning up on re-entry. Families could track it online, watching their loved ones sail across the sky like a digital ghost. Again, reactions were mixed. Beautiful, absolutely. A poetic use of technology, but also a potential precedent for space becoming a dumping ground for symbolic gestures. Some meaningful, others shallow. As space gets cheaper to access, more companies and individuals are treating orbit like a canvas. A place not just for science, but for statements. Art, advertising, experiments, and yes, cars. And this trend shows no sign of stopping. In fact, in 2021, Canadian startup Geometric Energy Corporation proposed launching a satellite that would display advertisements on a pixelated screen. The screen would be live-streamed from space, allowing people on Earth to pay for messages, logos, or even memes to appear on the satellite. A floating space billboard. It sounded ridiculous. And yet, several space firms were involved in making it happen, including SpaceX. Once again, the line between innovation and spectacle was blurred. Was this the future of low Earth orbit, corporate graffiti, and digital tombstones? Elon Musk himself has often said that humanity needs to become a multiplanetary species to ensure our survival. But in between Mars rockets and solar-powered colonies, his company also launched a mannequin in a convertible. Was it stupid? Maybe. Was it inspiring? Arguably. Was it unforgettable? Absolutely. Whether you see it as genius marketing or wasteful performance, the Space Tesla is now part of human history, a lonely relic of 21st century ambition, floating silently through the void. The time astronauts tried booze in orbit, space travel demands discipline, precision, and unshakable focus. But astronauts are still human, and humans, throughout history, have found one universal way to relax, celebrate, or simply take the edge off: alcohol. So naturally, at some point, someone tried to bring booze into orbit. Let's be clear, NASA officially prohibits alcohol aboard its spacecraft and the International Space Station. It's a strict policy, and for good reason. Alcohol can impair motor function, decision-making, and reaction time. In an environment where one wrong move could spell disaster, there's no room for error or intoxication. But the line between officially and actually has, at times, been blurred. The most infamous case occurred in the 1970s during the Skylab program. Skylab was America's first space station, launched in 1973. It was an ambitious project, allowing astronauts to live and work in space for extended periods. The missions were grueling, the living conditions were cramped, and the food was mostly terrible. To boost morale, some at NASA proposed adding a little touch of comfort: sherry. Yes, fortified wine. The idea was that astronauts could enjoy a small glass with their meals, much like airline passengers. NASA even collaborated with the Fairbanks Company to develop a special space-approved sherry that could be stored and served in zero gravity. It was loaded into specially designed plastic squeeze tubes. Space Capri Suns, if you will. Samples were tested on Earth and the astronauts approved, but when the news leaked to the public, the reaction was explosive. Critics accused NASA of being reckless and irresponsible. Editorials slammed the idea of drunken astronauts floating around expensive government hardware. Some politicians even threatened to cut funding. NASA caved. The sherry was pulled from the menu before it ever reached orbit. Officially, no alcohol was sent up with Skylab. Unofficially, there are rumors, unverified but persistent, that a small stash might have made it aboard, hidden in scientific equipment. The incident left NASA gun-shy. From then on, alcohol became a taboo topic in American space missions. But other spacefaring nations took a different approach. The Russians, for example, had a more relaxed attitude. During the Soviet era, cosmonauts aboard space stations like Salyut and Mir were known to receive small rations of cognac. Not for recreation, they insisted, but for medicinal purposes. Russian space doctors claimed that small amounts of alcohol could help with stress, digestion, and radiation absorption. Whether this was true or not, the practice persisted for decades. Cosmonauts often drank their allotment from little plastic tubes or sealed vials, designed to be easy to handle in zero gravity. Some even described it as a bonding ritual, a rare chance to unwind, laugh, and feel normal in an environment that's anything but. In 2010, a retired cosmonaut confirmed in an interview that cognac was still occasionally sent to the ISS, though in very limited quantities. He noted that Americans on board never partook, at least not officially. NASA continues to deny the presence of alcohol on the station, though when you're sharing a living space the size of a few school buses, secrets are hard to keep. Meanwhile, Japanese space researchers have taken things a step further, into the realm of experimentation. they've sent bottles of whiskey to the International Space Station. In 2015, Suntory, one of Japan's largest whiskey producers, launched samples of its aged spirits into orbit to study how microgravity affects the aging process. The experiment wasn't about drinking, it was science. Researchers wanted to see whether the lack of convection and sedimentation in space would produce a smoother, more refined flavour. The bottles spent over a year in orbit before being brought back to Earth. The results? According to Suntory's tasting panel, the space-aged whiskey was noticeably mellower and more complex than its Earth-bound twin, a fascinating and expensive experiment in orbital chemistry. There were similar projects with wine. In 2019, a dozen bottles of Bordeaux were sent to the ISS as part of a study by the European startup Space Cargo Unlimited. Like the whiskey, they spent about 14 months in orbit before returning home. When sampled by a panel of French sommeliers, the space wine showed surprising changes in flavour and aroma. The lack of gravity appeared to influence how the wine aged at the molecular level. Some tasters even claimed it had become more floral, more expressive, like wine from another world. These experiments were purely for research. No one aboard the ISS was popping corks or clinking glasses, but they opened the door to a future where alcohol might have a real place in space habitats. After all, if humanity is serious about settling other planets, or even building rotating space hotels, questions about leisure, culture, and indulgence become increasingly relevant. Will future Martian colonists brew beer using local water? Will space tourists sip cocktails in artificial gravity lounges? Will we toast to new worlds with wines aged in orbit? But until that future arrives, alcohol in space remains a curious footnote, tantalizing, controversial, and occasionally absurd. There's also the problem of physics. In zero gravity, liquids behave strangely. They don't pour, they glob. They stick to surfaces. A floating bubble of vodka could infiltrate an air filter or short out a circuit. Carbonated drinks are even worse. The carbonation doesn't separate like it does on Earth, leading to wet burps, a phenomenon astronauts do not recommend experiencing. In one test, NASA tried sending carbonated soda to space. Coca-Cola and Pepsi both created zero-gravity cans for shuttle missions in the 1980s. The idea was to provide astronauts with a taste of home and test the practicality of fizzy drinks in orbit. The results were underwhelming. The carbonation caused discomfort, bloating, and messy eruptions of soda foam in the cabin. The experiment was quietly scrapped. So while the image of an astronaut sipping a beer while gazing at Earth might be romantic, the reality is sticky, awkward, and medically inadvisable. That hasn't stopped people from trying. In recent years, several space-focused beverage startups have emerged. Companies like Zero Gravity Craft Brewery and Vostok have experimented with space-friendly packaging, ingredients, and even fermentation in microgravity. Their goal? Create the world's first truly space-safe beer. In one prototype, beer is stored in a special bottle that uses internal pressure to push liquid toward the mouth, bypassing the need for gravity. Another approach uses edible gels or foams that mimic the texture and flavor of alcohol without the mess. All of this points to one thing: humans will always find ways to bring their traditions with them, no matter how far they travel. Even into space. Whether it's a toast to Earth from lunar orbit, a sip of cognac after docking, or a quietly aged whiskey waiting in the void, alcohol in space reflects our strange, stubborn desire to remain us, even when the surroundings are utterly alien. The time someone tried to detonate a nuclear bomb on the moon, of all the outlandish ideas ever seriously considered in space history, few come close to the madness of this one. Project A119, a secret Cold War plan to detonate a nuclear bomb on the moon. Yes, you read that correctly. In the late 1950s, as tensions escalated between the United States and the Soviet Union, both nations scrambled for ways to demonstrate technological and military superiority. The Soviets had already stunned the world by launching Sputnik, the first artificial satellite, in 1957. America was desperate for a response. Something bigger, bolder, spectacular. So someone at the US Air Force thought, what if we nuked the moon? Enter Project A119. This top-secret project was spearheaded by the US Air Force in collaboration with the Illinois-based Armor Research Foundation. The idea was deceptively simple. Detonate a thermonuclear warhead on the lunar surface in such a way that the explosion would be visible from Earth with the naked eye. Not for military gain, not for scientific exploration, but for optics. The flash of light from a nuclear detonation on the moon was meant to awe the public and intimidate adversaries. A celestial display of power that would say without ambiguity, we control space. There were, however, some serious problems. First, the moon has no atmosphere. That means no blast wave, no booming sound, just a silent burst of radiation and debris. It wouldn't look like a dramatic mushroom cloud. At best, it would resemble a camera flash in the sky. Second, the dust and fallout. A nuclear detonation would scatter radioactive material across the lunar surface, possibly contaminating the only celestial body humans had any realistic chance of reaching. And at the time, the possibility of sending astronauts to the moon was becoming more feasible by the day. Third, the risk of failure. Getting a nuclear warhead to the moon in the 1950s wasn't exactly a slam dunk. Rockets were notoriously unreliable. If the launch failed and the warhead exploded in Earth's atmosphere, or worse, landed in the wrong country, it could have triggered a global crisis. Or worse, World War III. Despite all these glaring issues, the project advanced. A team of scientists was recruited to study the effects of the proposed explosion. One of them was a young graduate student named Carl Sagan. Yes, that Carl Sagan, the future voice of cosmos and champion of planetary science. He worked on models predicting how the moon dust would behave in the low-gravity environment after the detonation. Years later, when the existence of Project A119 was declassified, Sagan's involvement caused a brief stir. Some were surprised that a man so publicly dedicated to peace and cosmic wonder had once contributed to a nuclear plan. But context matters. He was young, idealistic, and deeply fascinated by how the explosion might help us understand lunar geology. Still, that doesn't make the idea any less wild. Thankfully, sanity prevailed. Project A119 was shelved, and attention turned to more productive goals, namely, actually landing on the moon. President Kennedy's announcement of the Apollo program in 1961 shifted the narrative from destruction to exploration. And yet, the dream of nuking space didn't die there. The Soviets had their own version, Project E4, a plan to detonate a nuclear device on the moon for similar reasons. That project also never came to fruition, but it showed how both superpowers had briefly flirted with using celestial bodies as message boards for nuclear muscle flexing. Even NASA, in its early days, considered the possibility of nuclear-powered missions. Not bombs, but propulsion systems. Project Orion, for example, envisioned a spacecraft propelled by the detonation of a series of nuclear explosions behind it. Theoretically, this pulse propulsion could reach the outer planets in record time. But Orion had one major problem. Testing it would violate every nuclear treaty ever written. The detonation of nuclear bombs in Earth's atmosphere, let alone space, became increasingly unthinkable after the Partial Test Ban Treaty of 1963. The world realized that nuking the cosmos, however thrilling it sounded on paper, was a terrible idea in practice. Still, that didn't stop the US military from testing the boundaries. In 1962, during Operation Fishbowl, the United States launched several nuclear warheads into the upper atmosphere to study their effects on space and the magnetosphere. One of these tests, dubbed Starfish Prime, detonated a 1.4 megaton warhead 400 kilometers above the Pacific Ocean. The results were dramatic. The explosion created a temporary radiation belt that damaged satellites and knocked out streetlights in Hawaii, nearly 900 miles away. The electromagnetic pulse, EMP, was so intense that it disabled electronics across a vast area. And that was just in Earth's upper atmosphere. Imagine the chaos of a similar explosion on the Moon. Starfish Prime was a turning point. The scientific fallout, pun intended, helped drive international agreements to limit nuclear activity in space. The 1977 Outer Space Treaty, signed by the US, the Soviet Union, and dozens of other nations, explicitly banned placing nuclear weapons in orbit or on celestial bodies. Still, the legacy of Project A119 remains a chilling what-if of space history. It serves as a reminder of how far humans were willing to go, not to explore space, but to conquer it in the eyes of rivals. In a sense, it's the ultimate example of ego-driven space science. No telescope, no rover, no base, just a flash. A statement, a symbol of dominance over something we barely understood. Had it happened, we might be living in a very different space age today, one where the Moon carries the scar of human vanity and military bravado. Instead, we were fortunate to choose landing boots over bomb craters. And yet, the ghost of that idea still lingers. In the modern era, with the rise of new spacefaring nations and militarized satellites, the question of weaponizing space hasn't gone away. It's just become quieter, more digital, more stealthy. Instead of nuclear warheads, today's space power plays involve jamming signals, disabling satellites, and deploying surveillance tech. But back in the 1950s, when the sky was a blank slate and the world stood on the brink, someone genuinely thought, what if we nuked the Moon? That alone earns it a place in the pantheon of the most outlandish and stupid things ever considered in space. The Columbia disaster and the deadly foam. Not all space failures are rooted in flamboyance or bizarre intentions. Some of the most tragic and, in hindsight, preventable space catastrophes have resulted from seemingly minor oversights that snowballed into fatal errors. Perhaps no incident better illustrates this grim truth than the loss of the Space Shuttle Columbia in 2003. At first glance, the mission seemed routine. Designated STS-107, Columbia carried 7 astronauts into orbit on January 16, 2003, for a 16-day science mission. The crew, a mix of American, Israeli, Indian American, and African American astronauts, was experienced, enthusiastic, and well-trained. They conducted dozens of experiments aboard the shuttle's middeck and Space Lab module, studying microgravity effects on biology, physics, and Earth observation. The mission itself went off without a hitch. The shuttle completed its tasks and prepared for re-entry on February 1st, but as Columbia began descending into the atmosphere, something went terribly wrong. The shuttle broke apart over Texas at hypersonic speeds. All 7 astronauts were killed instantly. It was a national trauma, a devastating blow not only to NASA, but to the dream of space exploration. But the true horror lay in the cause of the disaster, a piece of foam. During launch, a suitcase-sized chunk of insulating foam broke off from Columbia's external fuel tank and struck the leading edge of the shuttle's left wing. The impact occurred just 82 seconds after liftoff and went mostly unnoticed. NASA engineers saw footage of the foam strike but assumed, based on years of similar incidents, that it wasn't catastrophic. That assumption would prove fatal. The foam struck the wing with enough force to punch a hole in the reinforced carbon-carbon heat shield tiles. These tiles were critical. They protected the shuttle from the searing temperatures of re-entry, where the leading edge could reach up to 3,000 degrees Fahrenheit. With the breach, superheated plasma entered the wing structure, melting the aluminum frame from within. The shuttle's left wing disintegrated, and the spacecraft broke apart soon after. What made the tragedy especially painful was that the warning signs were there. Columbia wasn't the first shuttle to be hit by foam debris during launch. Foam strikes had occurred frequently during earlier missions, but had never caused a catastrophic failure, so they became normalized. Engineers raised concerns. Some even requested that Department of Defense satellites be used to image Columbia in orbit to assess the damage. But NASA leadership, suffering from a dangerous mix of bureaucratic inertia and risk habituation, dismissed the idea. They believed that even if there was a problem, nothing could be done about it in orbit. A rescue mission would have been nearly impossible within the short time frame. So the shuttle continued its mission, while the crew remained unaware that their fate had already been sealed. The Columbia Accident Investigation Board, CAIB, later published a scathing report that didn't just blame the foam, it blamed the culture. NASA, the report said, had grown complacent. A system that once questioned everything now ignored the most basic safety warnings. The decision-making process was flawed. Engineers were hesitant to challenge managers, and the agency had failed to learn from previous mistakes. The Columbia disaster was a mirror image of the earlier Challenger explosion in 1986, which also stemmed from poor communication and ignored engineering concerns. That incident involved a failed O-ring on a cold morning launch, again a technical problem that was known but underestimated. In Columbia's case, the tragedy was not the result of pushing boundaries, but of ignoring them. And here's the brutal irony. Foam wasn't supposed to be the danger. NASA's engineers had worried more about ice or metal debris falling off the shuttle. Foam seemed harmless. It was light, it was soft. But in the high-velocity environment of launch, even a soft material can become a deadly projectile. The physics of relative motion turned that chunk of foam into a bullet. After the disaster, the entire shuttle program was grounded for over 2 years. NASA was forced to redesign its external tank to reduce foam shedding. In later missions, astronauts performed in-orbit inspections of their shuttle's exterior using robotic arms and cameras. Contingency plans were developed for rescue missions. The culture of silence was replaced, at least temporarily, by a culture of vigilance. But the damage had been done. Columbia was the second shuttle NASA lost. 2 of 5 orbiters, Challenger and Columbia, were destroyed. 14 astronauts dead. The public's confidence shaken. And a deep, sobering realization that even after decades of spaceflight, we were still making elementary mistakes. What's especially haunting is how avoidable it was. The foam strike was visible in launch footage. Engineers flagged it within hours. Requests to investigate were denied not because of hard data, but because of belief. The belief that we've seen this before, and it's always been fine. That kind of thinking is what safety analysts call normalization of deviance, when repeated exposure to risk makes it feel acceptable. Columbia's crew had done nothing wrong. They completed their mission flawlessly. They re-entered Earth's atmosphere as heroes. And yet, they were doomed from the second minute of their flight. In a cruel twist, their final minutes were unknowable. The shuttle's sensors began failing one by one. The wing lost control. The cabin broke apart. It happened too fast for the astronauts to react. Analysis of the recovered cockpit voice recorder and data logs suggested they had no time to comprehend what was happening. The loss of Columbia serves as one of the most sobering reminders in space history. Sometimes, the stupidest things aren't flashy or dramatic. They're quiet, mundane, bureaucratic. A chunk of foam, an ignored email, a cancelled photo request, a shrug. And in space, where there's no room for error, those little things can become the difference between triumph and tragedy. The pizza delivery to orbit, in the age of ultra-fast shipping and drone deliveries, it's hard to surprise people. But back in 2001, a very special delivery was made, not across the globe, but above it. Pizza Hut, the global fast food chain, became the first company to deliver a pizza to space. This wasn't a metaphor. They actually partnered with the Russian space agency Roscosmos to send a vacuum-sealed pizza to the International Space Station, ISS. The delivery was part of a multi-million-dollar marketing campaign designed to show off the company's brand and apparently make history in the most absurd way possible. Let's unpack how this culinary stunt came to be. and why it might be one of the weirdest marketing moves ever made beyond Earth. The year was 2001. The ISS had only recently become inhabited, with permanent crews arriving and rotating for the first time. It was a symbol of international cooperation and cutting-edge technology. And yet, into this high-stakes scientific environment came pepperoni. Pizza Hut worked closely with Russian food scientists to develop a space-safe version of their classic pie. Normal pizza wouldn't work in microgravity. Ingredients could float away, grease could infiltrate sensitive equipment, and moisture content needed to be tightly controlled to avoid spoilage. So they created a smaller, compact, single-serving salami pizza. Pepperoni didn't make the cut because it spoiled too quickly. It was preserved using sterilization techniques and sealed in a way that would keep it fresh for up to 60 days. The cheese and sauce had to be slightly reformulated to remain stable in the pressurized, low-humidity environment of the ISS. And yes, it was taste-tested in orbit. Cosmonaut Yuri Usakov was the first human to eat a slice of commercial pizza in space. He gave it a thumbs up on camera, though later interviews suggest the experience was more novel than delicious. The PR stunt didn't end there. Pizza Hut's logo was emblazoned on the side of a Russian Proton rocket, marking the first time a fast food chain had branded a launch vehicle. For a few months, Pizza Hut's name was literally on the frontier of space exploration. The cost? An estimated $1 million for the ad deal alone. It wasn't the only time food and marketing collided in orbit, but it was the most ridiculous. While sending pizza to space might sound like a whimsical victory for humanity's culinary ambitions, it also raised deeper questions about commercialization in space. Should the final frontier be open to corporate advertising? Is orbit the next billboard? NASA, for its part, wanted nothing to do with it. The US Space Agency strictly prohibits the use of its missions, logos, and astronauts for commercial endorsements. That's why Pizza Hut had to partner with Roscosmos. The Russian Space Agency, perpetually underfunded and strapped for cash in the post-Soviet era, was far more open to private sponsorships. This wasn't the first time Roscosmos dabbled in commercial deals either. Over the years, they've explored opportunities ranging from space tourism to advertising rights for onboard experiments, and even sponsorships on spacesuits. In one infamous instance, they discussed putting ads inside the Soyuz capsule, so cosmonauts would be surrounded by logos on their way to orbit. These deals helped keep their program afloat, but they also raised eyebrows. Critics argued that turning spaceflight into a corporate billboard undermines the scientific and cooperative spirit of the ISS. Others pointed out that if these funds kept missions running, maybe a little cheese and pepperoni was a small price to pay. In a more subtle form, commercialization continues today. Several companies have sent branded products into orbit, everything from makeup to watches, mostly as part of publicity campaigns. Red Bull sponsored a stratospheric jump. Samsung launched space selfies. Even KFC launched a chicken sandwich to the edge of space with a high-altitude balloon. But Pizza Hut still holds the crown for actual orbital delivery. Of course, food in space has always had a complex history. From the early days of toothpaste tube meals in Mercury capsules to freeze-dried entrees on Apollo, eating has always been a challenge in zero gravity. The ISS uses advanced heating systems, sealed packages, and vacuum-stable food trays to deliver decent nutrition and acceptable taste. Even then, crew members crave variety. That's why national dishes are sometimes included on missions. Japanese ramen, Italian espresso machines, and Israeli falafel have all made appearances aboard the ISS. Food becomes a source of comfort, identity, and morale. But pizza, that was always the elusive dream. NASA astronauts had been requesting pizza for years, but the logistics and microbial risks were too high, until the Russians, incentivized by cash and creativity, gave it a try. Ironically, in 2017, 16 years after the Pizza Hut stunt, NASA finally let astronauts make pizza on the ISS, using pre-packaged ingredients and tortillas instead of dough to prevent crumbs. The video went viral. The crew, floating in zero gravity, built and spun their custom pizzas while laughing and flipping pepperoni slices like juggling acts. Space pizza had evolved from a marketing gimmick to an actual morale-building activity. In the coming decades, food in space will only become more important. With missions to Mars and long-duration lunar bases on the horizon, space agencies are investing heavily in growing food in orbit. Lettuce, radishes, mustard greens, and zinnias have all been grown aboard the ISS. One day, astronauts might harvest tomatoes, bake bread, and yes, assemble full pizzas with fresh ingredients. Until then, Pizza Hut's space slice remains a strange but historic milestone. It's a reminder that sometimes human curiosity doesn't end at science. It includes comfort, flavor, and branding too. The cosmos may be a vacuum, but humans always find a way to bring their culture with them, whether that means planting a flag, playing golf on the moon, or ordering delivery to orbit. The space toilet that nearly broke the ISS. When you think about space exploration, visions of rocket launches, moonwalks, and interstellar discoveries often come to mind. But there's one aspect of living in space that rarely gets the spotlight: dealing with human waste. It might sound unglamorous, but in the confines of the International Space Station, ISS, handling bodily functions is a daily, vital, and sometimes hilariously complicated task. The space toilet, a seemingly simple device, has actually been one of the most notorious sources of technical headaches and unexpected crises in orbit. Unlike on Earth, where gravity naturally pulls waste away, zero gravity means that everything floats. Imagine trying to do your business without gravity to help, and you'll start to understand why space toilets are so finicky. Early spacecraft had rudimentary solutions, bags and containment devices, but for long-duration missions, astronauts needed a reliable, hygienic toilet system. NASA developed the Waste Collection System, WCS, for the Space Shuttle, and later the ISS, using a combination of airflow suction and mechanical parts to simulate gravity and funnel waste into storage tanks. But the system was far from perfect. The biggest problem, the tiniest clog. In 2008, a seemingly minor malfunction in the Russian segment of the ISS turned into a full-blown space toilet crisis. The toilet, designed decades earlier and modified for spaceflight, began to leak urine into the cabin's interior. The cause was a faulty valve that prevented urine from properly flowing into the storage tank, allowing it to back up and leak. As you might imagine, this wasn't just gross, it was dangerous. Urine in the microgravity environment could float freely, damaging sensitive equipment, contaminating air filters, and posing health risks to the crew. To make matters worse, the smell was unbearable. The astronauts had to wear masks and scrub the cabin continuously. NASA engineers scrambled to diagnose and fix the problem from Earth, sending detailed instructions and replacement parts aboard cargo ships. Over the course of several weeks, the crew performed complex repairs, removing panels, clearing blockages, and carefully reinstalling components, all while orbiting hundreds of miles above Earth. The episode became so famous internally that astronauts nicknamed the malfunctioning toilet the porcelain throne from hell. This wasn't the first or last toilet disaster in space. In 2010, the American segment of the ISS experienced a toilet backup caused by a stuck valve, leading to another leak and foul odor. Once again, the crew had to spend days troubleshooting a device meant to make life easier. Over the years, these failures have had hilarious and frustrating consequences. Astronauts have had to resort to wearing diapers during spacewalks, when they couldn't safely use the toilet. They've devised makeshift toilet paper substitutes and engineered creative fixes out of duct tape and spare parts. The space toilet story highlights a surprising truth. The mundane things we take for granted on Earth become monumental challenges in space. The Soviet space dogs and the ethics of animal testing in orbit. Before humans first ventured into space, the pioneers of the cosmos were not astronauts, but animals. specifically dogs, monkeys, and other creatures sent aloft to study the effects of spaceflight on living beings. Among the most infamous were the Soviet space dogs, whose stories are a mix of scientific progress, political propaganda, and ethical controversy. In the early years of the space race, both the United States and the Soviet Union raced to send living beings beyond Earth's atmosphere. The Soviets chose dogs, believing they were better suited to the harsh conditions and that their smaller size and calm demeanor would increase survival chances. The first Soviet space dog was Laika, launched aboard Sputnik 2 on November 3, 1957. Laika was a stray from Moscow streets, trained for spaceflight, but with no plan or means for her safe return. The mission was a political statement to the world, demonstrating Soviet technological prowess. Sadly, Laika died within hours from overheating and stress. The technology to safely bring her back did not yet exist. The mission sparked international outcry and protests from animal rights groups, raising moral questions about the treatment of animals in the name of science. But the Soviets pressed on, sending dozens of other dogs into orbit, many in pairs named with similar prefixes: Belka and Strelka, Veterok and Ugolyok, and so on. Some dogs survived multiple orbits and returned safely, contributing vital data on the physiological effects of weightlessness, radiation, and confinement. Their missions helped pave the way for human spaceflight. However, many dogs perished in crashes, malfunctions, or during re-entry. The Soviet space dog program was shrouded in secrecy, with many missions unreported or only revealed decades later. Details about the conditions these animals endured, tight capsules, limited food and water, extreme G-forces, and psychological stress paint a grim picture. The stories of these dogs became propaganda tools as well. Successful returns were celebrated widely, with surviving dogs paraded as heroes. Some even became celebrities, meeting dignitaries and starring in Soviet media. Yet the ethical questions linger. Did the ends justify the means? Were these animals sacrificed without their consent for geopolitical gain? The issue is complicated further by cultural differences and the context of the Cold War, when secrecy and competition often overshadowed humanitarian concerns. In the West, similar programs involved sending monkeys and chimpanzees aboard rockets. The most famous was Ham, the first chimpanzee launched into space in 1961 by NASA. Unlike Laika, Ham survived and returned safely, but the ethical debates about animal testing persisted. Even today, animal testing in space remains controversial. With advances in technology, scientists now use sophisticated simulators, computer models, and tissue cultures to reduce the need for live subjects. But the legacy of the space dogs serves as a somber reminder of the costs of exploration, the lives lost or endangered in the quest for knowledge. And it highlights the often overlooked dimension of space history, that before humans stepped beyond Earth, countless animals were the first to face the void, unknowingly making sacrifices for the future of space travel. Spacewalking with power tools. When astronauts went DIY. One of the most awe-inspiring sights in space history is that of astronauts performing extravehicular activities, EVAs, or spacewalks, outside their spacecraft. These brave pioneers venture into the vacuum of space, tethered by a lifeline and armed with tools to repair, maintain, or upgrade equipment. But what happens when your space toolbox isn't quite up to the task, and you have to improvise with what you have? Early spacewalks were filled with unexpected challenges, but none more memorable than when astronauts resorted to some truly bizarre DIY solutions floating hundreds of miles above Earth. In the early days of NASA's Space Shuttle program, and later on the International Space Station, ISS, astronauts were essentially mechanics working in a hostile environment. They carried specialized tools designed to function in microgravity, but these tools were bulky, limited, and not always perfectly suited for every repair. One infamous example happened during the first Hubble Space Telescope servicing mission in 1993. After the Shuttle Endeavour's crew installed new instruments, they had to deal with a stubborn lens cover that refused to come off. With limited options, astronaut Catherine Thornton used a surgical glove as a grip aid, wrapping it around the stubborn cover to get better traction. A classic MacGyver moment in orbit. Similarly, astronauts have had to invent makeshift tools from everyday items on board. Velcro strips, duct tape, zip ties, and plastic clamps become the space handyman's best friends. On one mission, a frayed antenna cable was repaired using a plastic bag twisted and taped to reinforce the connection. Not quite NASA standard, but it worked. In fact, duct tape deserves a special mention as the unsung hero of space. Its versatility has saved countless missions. When a protective thermal blanket on the ISS started peeling, astronauts patched it up with duct tape, preventing potential damage from extreme temperatures. The tape's use dates back to the Apollo program, where it was employed to fix everything from lunar rover tires to life support equipment. But not every DIY fix was as practical. During an EVA on the STS-51F shuttle mission in 1985, astronaut Jeff Hoffman attempted to free a stuck solar array panel. Lacking proper tools, he grabbed a hammer-like object and started hitting the panel to loosen it. While effective, the repeated pounding caused vibrations that risked damaging sensitive components and unnerved mission control back on Earth. The event underscored how delicate and unforgiving space hardware can be. A hammer isn't always your friend in orbit. Another memorable stupid thing was the use of an improvised antenna made from a broomstick during the Soviet Salyut space station missions in the 1970s. When a communications antenna malfunctioned, cosmonauts fashioned a replacement using parts of a common cleaning tool. It worked well enough to restore radio contact, but the image of a broomstick flying through space remains one of the quirkiest fixes ever attempted. The constant need for improvisation has led NASA and other agencies to pre-pack specialized toolkits with modular and multi-use instruments, along with detailed instructions and contingency procedures. Astronauts also train extensively on Earth in neutral buoyancy labs, simulating weightlessness, practicing everything from routine maintenance to emergency repairs. Still, no amount of training can fully prepare crews for the unpredictability of working outside a spacecraft. Space is hostile and unforgiving, and tiny mistakes can have huge consequences. This is why astronauts often have to think on their feet, inventing novel solutions on the spot with limited resources. These ad hoc repairs can be dangerous too. Exposure to vacuum, radiation, and extreme temperatures means any extra time spent outside risks life-threatening problems. The bulky suits limit dexterity and vision, turning simple fixes into hours-long ordeals. One striking example of dangerous improvisation occurred during the 1997 STS-86 mission, when astronaut David Wolf had to replace a malfunctioning solar array hinge on the Russian Mir space station. The repair took 6 hours, during which Wolf repeatedly risked suit punctures and equipment failure. His success was hailed as heroic, but it also highlighted how much risk astronauts accept to keep stations functioning. The space agencies are learning from these experiences. Future missions to the Moon, Mars, and beyond will require more reliable, autonomous systems with robotic backup to minimize human EVAs and dangerous improvised repairs. Still, the legacy of astronauts wielding duct tape, broomsticks, and surgical gloves remains a testament to human creativity and determination. When the chips are down and the universe is testing you, sometimes the only option is to make do, even if it means doing the stupidest things ever tried in space. The spacefire experiment that almost burned up a spacecraft. Fire is one of humanity's greatest tools and one of its greatest enemies. On Earth, we rely on fire for warmth, cooking, and industry. But it's also something we've learned to control carefully. In the enclosed, oxygen-rich environment of a spacecraft, fire becomes an existential threat. Yet, despite the obvious danger, some early space experiments flirted dangerously with fire, producing some of the most reckless and stupid attempts to study combustion in microgravity. The story begins with the Soviet Union's Salyut, and later Mir space stations, and NASA's Skylab and shuttle programs. Scientists wanted to understand how fire behaves in microgravity, a question vital not only for safety, but also for improving combustion science in general. In zero gravity, hot gases don't rise as they do on Earth, so flames look very different, often spherical and slow-moving. This changes how fire spreads and how smoke behaves. But simulating and containing fire in a cramped spacecraft full of delicate instruments, oxygen tanks, and flammable materials is an immense challenge. One particularly infamous incident occurred in 1997 aboard the Russian space station Mir. A simple experiment to burn a small sample of material nearly became a disaster. Cosmonauts were conducting a combustion experiment inside a sealed chamber. The goal was to study how flames propagated in microgravity, hoping to improve fire safety on future missions. But the experiment went wrong. A leak developed in the chamber, allowing smoke and flames to escape into the station's air supply. The smoke quickly spread, triggering alarms. The crew scrambled to don masks and activate emergency ventilation systems to clear the air. The station's automated fire detection system also kicked in, activating emergency procedures. For a moment, the crew feared a catastrophic fire that could jeopardize the entire station. Fortunately, quick action prevented disaster. The source of the leak was sealed, and air filtration systems restored breathable conditions. The incident was a wake-up call for all space agencies. Fire in space is not just a risk, it's a catastrophe waiting to happen. Why was the experiment so reckless? It turns out that the design of the experimental chamber had flaws, including weak seals and poor fail-safes. The risk assessment was inadequate, relying too heavily on automated systems rather than robust physical barriers. Even more concerning was the crew's limited ability to respond in time due to the confined spaces and limited emergency gear. Despite these dangers, combustion experiments continued. NASA's space shuttle missions conducted controlled burns inside the space shuttle's mid-deck glove box and other containers designed to contain fires safely. These experiments produced fascinating results. Flames behave as spheres, soot particles clump differently, and some materials burn more slowly or more aggressively than on Earth. This knowledge is invaluable for spacecraft design, fire prevention, and understanding fundamental combustion physics. However, in 2013, the crew aboard the ISS experienced a scary incident involving a flash fire during routine operations. While not a full-blown fire, an electrical component inside a piece of equipment overheated and emitted smoke and sparks. The crew quickly responded by shutting down power, donning masks, and isolating the module. Thankfully, no one was hurt, and damage was limited, but the incident highlighted how vulnerable spacecraft are to fire hazards, even with advanced safety measures. Fire safety in space is uniquely challenging because traditional methods like water sprinklers or foam suppression can be disastrous in microgravity. Water droplets can float freely, potentially damaging electronics or obscuring vision. Foam and powder suppressants might interfere with sensitive systems. Instead, spacecraft use specialized fire extinguishers that release inert gases like carbon dioxide or nitrogen to starve fires of oxygen. They also have advanced smoke detectors, air scrubbers, and strict protocols on materials allowed on board. Flammable liquids are tightly controlled or banned. Even crew behavior is regulated. No open flames, no smoking, obviously, and stringent electrical wiring standards. Still, the temptation to experiment with fire remains. In the quest for scientific knowledge, some combustion studies push the boundaries, sometimes dangerously. One notable ongoing program is NASA's flame extinguishment experiment, FLEX, designed to understand how to control and suppress fires in microgravity better. Scientists use drop towers, parabolic flights, and space-based facilities to observe flames in carefully controlled conditions. The goal? to develop fire detection and suppression systems that could be deployed in future spacecraft, lunar bases, or Mars habitats, places where a fire could quickly turn deadly. There's also research into cool flames, low-temperature combustion phenomena that could improve fuel efficiency and safety in engines, potentially useful for space propulsion. But despite these promising advances, the memory of near disasters lingers. Space agencies have become far more cautious about fire experiments, imposing rigorous safety reviews, redundant containment systems, and extensive crew training. The fire in space remains one of the top fears of astronauts and mission planners alike. The ultimate lesson: fire is a fundamental part of human civilization, but a mortal enemy in space. Pursuing knowledge about fire's behavior off Earth is essential, but must be balanced with the utmost caution. And yet, humanity's stubborn desire to tinker and understand sometimes leads us down stupidly dangerous paths. Almost burning up a spacecraft to learn about flames is a perfect example of that paradox. It's a testament to our curious nature and a warning of the fine line between exploration and catastrophe. The solar-powered clothes dryer that failed spectacularly. When you're living on Earth, drying your laundry is simple. Hang it outside or toss it in a dryer. But in space, no atmosphere, no wind, and microgravity make even this mundane task a massive challenge. The idea of drying clothes in orbit has been tackled in several ambitious and sometimes hilariously misguided ways, culminating in one of the most baffling failures in space station history: the solar-powered clothes dryer experiment. The International Space Station, ISS, is a marvel of engineering designed for long-duration habitation. Yet astronauts still face the everyday chore of managing clothing. Space missions carry a limited supply of clothes, so proper hygiene and reuse are critical. In the 2000s, NASA and its partners explored ways to clean and dry clothes in orbit to reduce resupply costs and waste. Washing machines were impractical, too heavy, complex, and water-intensive. So drying became the focus. Inspired by the abundance of sunlight in space, one company proposed an innovative solution: a solar-powered clothes dryer designed to harness the sun's energy outside the ISS. The concept was elegant. Straps and frames would hold garments outside the station, letting solar radiation evaporate moisture, while microgravity would prevent dripping. The device was compact, low power, and promised to reduce the frequency of sending fresh clothes from Earth, saving money and logistical headaches. But it didn't work. When the solar dryer was deployed on a small external module attached to the ISS in 2011, it immediately ran into trouble. First, the vacuum of space is a harsh environment. Temperatures fluctuate wildly, from blistering heat in direct sunlight to freezing cold in shadow. The clothes became brittle and stiff, unable to dry evenly. Second, without gravity, moisture doesn't drip off. It tends to cling or freeze onto fabrics, leaving damp patches that neither evaporation nor radiation could fix. Third, the station's orbital speed of 17,500 mph meant the dryer experienced extreme and rapid temperature swings every 45 minutes as it circled Earth. These thermal stresses damaged the dryer's materials and mounting systems. Finally, the solar dryer's placement exposed clothes to micrometeoroids and orbital debris impacts. A tiny particle, less than a millimeter in size, pierced a garment, ruining it instantly. Astronauts monitoring the experiment reported that clothes looked fried, stiff as cardboard, and ultimately useless. The device was soon decommissioned, and the clothes returned inside. The failure sparked both frustration and humor among the crew. Some joked about space fabric that could stop bullets, and started calling the ruined garments space armor. But the experiment exposed the complex realities of applying Earth-based solutions in space. Drying clothes requires managing moisture removal, temperature control, and mechanical agitation, all difficult without gravity or atmosphere. Later approaches shifted toward using fabrics designed to wick moisture and resist odor, combined with regular replacement rather than washing and drying. Some newer spacesuits and clothing incorporate antimicrobial materials and specialized ventilation to minimize odor buildup, reducing the need for frequent laundry. NASA has also explored ozone and ultraviolet sterilization chambers as a way to refresh clothes without water or drying. Still, the dream of a simple, reliable space dryer remains elusive. With future deep space missions and lunar habitats on the horizon, the challenge becomes even greater. On Mars, for example, lower gravity and a thin atmosphere present new problems. Washing and drying clothes without Earth's natural systems will require ingenious engineering, likely combining controlled environment chambers with advanced textiles. The solar-powered dryer failure is a perfect example of how good intentions and clever ideas can falter in space. What looks simple on Earth becomes fiendishly complex off-planet. It's a reminder that space exploration isn't just about rockets and science. It's also about mastering the mundane, the everyday, and sometimes the downright ridiculous. Because in space, even drying your socks can become one of the stupidest things ever tried. The tennis ball experiment that went totally wrong. In the quest to understand physics in microgravity, scientists and astronauts have conducted countless experiments aboard the International Space Station, ISS. From fluid dynamics to combustion and biology, these studies help us unlock the mysteries of how things behave beyond Earth. But some experiments, while well-intentioned, have ended up being downright absurd, like the infamous tennis ball experiment that spiraled out of control. The experiment was deceptively simple. To study the behavior of spinning spheres in microgravity, researchers decided to release a tennis ball inside the station's pressurized modules. They wanted to observe how rotation affects motion without the influence of gravity, hoping to glean insights applicable to aerospace engineering and sports science. Sounds harmless, right? Well, not quite. The trouble began the moment the ball was released. Unlike Earth, where a spinning ball quickly encounters air resistance and gravity, inside the ISS's confined zero-gravity environment, the tennis ball kept floating, spinning, and bouncing indefinitely. Astronauts soon discovered that the ball was harder to catch than anticipated. The small volume and limited space of the station meant the ball ricocheted off walls, equipment, and even floating computers, sometimes hitting crew members. It became a chaotic game of zero-G tennis, but without rackets or clear boundaries. More problematically, the tennis ball's fuzzy surface started shedding fibers. These tiny particles, free-floating in the cabin, posed a hazard. The fibers could clog air filters, interfere with electronics, or be inhaled by astronauts. Dust and debris in microgravity don't settle as on Earth. They linger, circulating with ventilation systems, making them a persistent annoyance and potential health risk. The crew had to improvise ways to corral the fibers, using sticky pads, vacuum cleaners, and adhesive tape to capture the fuzz. Adding to the chaos, the tennis ball sometimes blocked access to important equipment or floated into sensitive instruments, forcing astronauts to pause their work to retrieve it. The experiment soon turned from scientific to comedic, with crew members joking about the rogue tennis ball terrorizing the station. Mission Control began questioning the necessity of the study, wondering if the disruption was worth the limited scientific payoff. Eventually, the tennis ball was sealed away and the experiment was abandoned. This incident serves as a humorous but instructive lesson. Even small, simple objects behave unpredictably in microgravity, and what seems trivial on Earth can quickly become a nuisance or danger in space. The tennis ball story also reflects a broader challenge of space research, balancing curiosity and experimentation with the practical realities and risks of living in an enclosed, controlled environment. Since then, experiments involving loose objects have been tightly regulated. Scientists now rely more on virtual simulations and tethered or contained test subjects to avoid creating debris hazards. The rogue tennis ball is a reminder that microgravity rewrites the rules of physics, and that sometimes the simplest ideas can lead to the stupidest outcomes. The space pen myth and other ridiculous stories. To cap off our journey through some of the most absurd, fascinating, and downright stupid things ever tried in space, let's talk about one of the most persistent space myths, and a few other ridiculous stories that show just how quirky space history can be. You've probably heard the tale, NASA spent millions developing a special space pen that works in zero gravity, while Soviet cosmonauts just used pencils. It's a story often told to highlight supposed American wastefulness or Soviet frugality. But like many urban legends, the truth is far more interesting and less flattering to both sides. The so-called space pen was actually invented independently by a private company, Fisher Pen Company, which developed the AG7 pen in the 1960s. This pen uses pressurized ink cartridges to write in zero gravity, underwater, at any angle, and in extreme temperatures. NASA did not fund this invention, but later bought the pens for use on space missions because pencils, while functional, posed hazards. They could break, leaving flammable graphite shards floating in the cabin, which could damage equipment or be inhaled. The Soviets also used space pens, debunking the myth that they stuck to pencils. This myth persists because it taps into a narrative about bureaucracy and ingenuity, but obscures the real complexity of managing tiny details in space. Beyond the pen, many other ridiculous stories dot space exploration's history. For instance, during the Apollo 12 mission, astronauts were targeted by a lightning strike during launch seconds after liftoff, a freak event that knocked out the spacecraft's telemetry and electrical systems. The crew barely avoided disaster by quickly resetting circuit breakers, a fix so simple yet so critical, it's sometimes jokingly called the stupidest near-death incident in space. Or the time in 1983 when Soviet cosmonauts aboard Salyut 7 station experienced a near-catastrophic fire caused by an electrical short circuit. The smoke alarm didn't work, and the crew had to locate and extinguish the blaze manually in near darkness. The list of these bizarre incidents is long: a parachute failure that caused a capsule to crash land in Siberian woods, an astronaut accidentally dropping a camera that floated away forever, a probe mistakenly launched with a faulty instrument and lost in space, or cosmonauts arguing over how to divide shared food supplies in orbit. All of these stories share a common theme. Exploration pushes humans to the edge, where simple mistakes, quirky decisions, or sheer bad luck can spiral into problems of cosmic scale.